Okay, general feelings about this FRQ. Easy? Okay, well let's hope that's the case. One thing I want to review, okay, especially calculator active. When generally speaking, whenever you see a really kind of crappy looking expression, it's going to be calculator active. And what I want to review with you is not necessarily the, because when I started this problem, I typed this thing into my normal calculator screen, and without realizing it until the next part of the, I was like, that was a mistake. I do not want to have to keep typing this in. Did anybody else have that issue? Did anybody type it in the y = screen just so that they didn't have to keep typing it? Okay, good. That's what I wanted to review. Okay, so we're talking about, nope, that's not what I wanted to do either. Basically, you should absolutely, whenever you have a really crappy looking expression, because there's so many opportunities to make a mistake with it, right? The best way is to type it in the y = screen and then use it. Now, I know that you guys have mentioned in the past that you use the vars button and you go over, and that is fine. You can do that. I want to reiterate the idea that if you hit the alpha button in the trace, this is what will pop up. That y vars that you're trying to access with the vars button, you can get so much faster. Now, that's assuming you have a relatively current calculator. No idea how you would do it on yours. No idea how you do it on yours. I don't know. And hopefully you know how to do that. Like ultimately that's the thing, because and of course after you type this in, so maybe it does take a little more time to analyze it and make sure that you did type it in correctly, because if you didn't and you made a sign mistake somewhere, forget it. Now, this is part of the deal with the calculator active problem, because you don't really have to show a lot of work. And so it could be kind of an all or nothing type problem. All right, anyway, all right, here we go. What we're trying to find is the acceleration of the particle. They gave us a velocity. So of course, in order to find the acceleration at time = 3, what are we doing? Derivative of the velocity. Okay, so a couple things that you want to think about when you're doing this. All right, they're asking for acceleration, so you probably should have an a of t somewhere in there. Okay, now that being said, I don't think it's required when we look at the scoring guidelines. All right, but you are trying to find acceleration. And although the reader knows that the derivative of the velocity is acceleration, it's probably worth your while to tell them that you know it, right? That you know that this is the derivative of the velocity. And then, okay, we're really looking for at time 3, and maybe you could have just gone right to here. But it's tricky, right? Like you don't want to write too much, but you want to write enough. And you want to convey to the reader that you get what you're supposed to do. All right? And at this point, that is all any of the work you really need to show. I would say maybe, actually now that I think about this more, this is probably not necessary. This one probably is. Okay? But we'll see what the scoring guidelines say in a second. But you don't have to write any more work than that, because all the rest of this is done. This is done on the calculator. Okay? And you don't need to write the derivative of this and this is it. This is enough. Okay? And I don't remember what it ended up being. It's like -2 or something like that. Do you guys have it? -2.118. Could it be 7? Could it be 9? You had 8. If you truncate it, is it a 7? Is anybody a truncator in here? Or are you all round like normal humans? Okay, fantastic. Which is, again, it's fine. It doesn't matter. You don't have, this is the thing that astonishes me about this exam. You are high-level math students, but they don't expect you to know how to round correctly. It's kind of funny. I don't know. It always comes up, okay? This always comes up because I didn't put it on there. Of course you have to use this, right? You have to know where you start. Bless you, okay? So in reality, bless you. So what you have to do, all right, position. Okay, so there's a couple things that you could say for position, right? What are the variables that we use for position? Sometimes we say x of t, right? What else do we say? S of t, right? Does it matter? Absolutely not. Makes no difference, okay? The general idea here, now, of course, what I'm about, actually, I'm not going to do that. Let's not do that. I'm going to get rid of the s just because I'm going to give myself more room. It doesn't matter which one you use, though, just so we're clear. What I was going to do was put a big equal sign next to the whole thing, and please, yeah, that's terrible. What's the idea here? What are we trying to do? The integral of, right? So in this case, we're just taking the integral of v of t, just like that. dt, don't forget the dt, okay? Now, there's always, for this problem, now here's where it's going to change a little. X of 3 is going to be -5, right? That's my starting position, plus v of 3 dt. Okay. Now, I would say, if I were to guess, this is probably not in the scoring guidelines. This is. Because we want to know at time 3 what the position is. So at time 3, it starts at -5, right? At time 0, it's -5. And I understand that sometimes they will have negative times, which is fine. Is it not -5? Is it -5? It's negative. Okay. What's your question?
So I found the integral, and then I found my answer, and then I did -5 at the end. Is that so?
Good question. We'll look at the scoring guidelines in a second. But you understand why this makes sense, though, as well, okay? Yep, no, I understand. All right, so then, again, this is calculator. And I would not try to do these in parts. I would probably type it in like this, okay? But actually, actually, that's not even right. Sorry, I gotta fix that. That is not right. How come you didn't correct me on that? Where does the 3 come in? Yeah, the limits of integration. 0 to 3. Because it moves from 0 to 3. Okay? All right, there we go. I was like, how are we going to integrate that? We don't, it's an indefinite integral. That doesn't work. All right, so we plug that in the calculator. What do we get?
-1.760.
Agree? Okay. So we'll look at the scoring guidelines because that's a good point. Do you have to do it all at the same time? Can you do that and then add the -5? Yeah, I don't know. All right. Part C. And here's the thing that was nice about this, right? Once we entered that expression into the y equals screen, you don't have to type it over again. You can just get the y1 back in the integral formula in your, math 9, and you're good to go. Okay. Right, so this is from 0 to 3.5 of v of t dt, 0 to 3.5 of the absolute value. Which one's which? One is displacement, one is distance. Do you remember which one is which?
Distance is absolute value. Displacement is unknown.
Maybe.
Well, because if you think about it,
That's what I have.
like the negatives, yeah, the negatives would like cancel out some distance, and then that would be displacement. But if everything's positive, you just have the most distance.
When we talk about distance, let's think about it too. What are we talking about when actual distance? We're talking about this particle, how much distance it travels. Displacement is just how far away it is from where it started. Okay, it totally excludes that sort of overlap, that doubling back that I don't do when I drive, right? I refuse to double back. I won't do it. But I won't make left turns either, so there's that. All right, so let's say you can't keep it straight. I mean, this problem asks us to find both anyway. This is a sort of a panic kind of strategy in the middle of the test that you can't keep straight. I'm purposely not answering the question, okay? If you notice, I've not answered which one is which. This problem asks you to find both anyway. Not every problem is going to ask you to find both. But because we've entered that expression into our calculator in the y equals screen, it would be easy to calculate both very quickly, right? And so if you can't, which one, generally speaking, if you just think about in general, which one's going to be bigger? The total distance traveled or the displacement? Total distance traveled, because all that doubling back adds up. The displacement we don't count for. So since if you can't keep it straight, you're going to find them both anyway, right? So let's find them both anyway. And what I guess the point of what I'm saying is that on the exam, if you decide you can't figure it out and keep it straight, find them both. The distance one is going to be bigger most of the time. The only time it wouldn't be, right, is if they're equal. Then I don't know how to help you. Okay, maybe something in what we're about to do will help you remember it. Okay. All right. So I'm going to tell you exactly what I did because I'm going to be honest with you. Sometimes I can't remember what it is either. Now, I will say this. I wrote both of them. That doesn't mean, please do not write both of them. If you're a rounder and not a truncator, just keep doing that, okay? This is more for me when I grade your stuff, okay? And I wrote the sentences after I did the calculations. Because then I was like, oh, this one must be the distance. Because guess what? It's bigger. So absolute value, yes, absolute value is distance. No absolute value is displacement. Now, you could write this in different ways. I wrote it over the interval because they gave us this problem in terms of intervals at the original. You could have said from time 0 to time 3.5 seconds. Or it's probably 3.5 and they probably would have taken it, okay? All right, how many had that? Okay. Questions about it? Last but not least. A second particle moves along the x-axis with position given by x sub t. Okay, at what time are the two particles moving with the same velocity? So what they're asking for essentially is, and I'm not suggesting you write this, but just when does x prime of 2 equal x prime of t? So you have options here too. Okay. What did you guys do to do this?
Just plug the displacement and then the function.
What? So you graphed it, found the points of intersection. Yep.
I derived x to the t, so I got 2t minus
2 minus.
and then I set that equal to v of t, and then I put it all on the side and put that in my calculator from the 0.
Okay, so found the 0. That's another way to do it. Some of you know, do you know you have a solver, an equation solver on your calculator? You don't know how to use it? Okay, well let's talk about how to. I think I did integrate the first one. Let's see. In your math menu, let me go here. At the very bottom, you have something called numeric solver. Oh yeah, I did already. Oh wait a minute. It's not x of but x of t. That's silly. Let me fix this. What is x of t actually in this problem?
V of t.
Yeah, this is v of t. Okay. So in my equation, So on your numeric solver, math C is what is it on mine. Okay, so what I did in the first equation, so you have this E1 in the first little box like this, I typed Y1, right? Okay. In E2, I did integrate it, and I just put in 2x minus 1. That's this. Okay. All right. And then I just hit OK. Look, the other ways that you guys are describing absolutely work, totally fine. If that's what you're comfortable with, go for it. To me, this one just saves time, all right? Hit the math button, and then it's all the way at the bottom, C. Okay. Yep. So let me take a picture of this. Okay, and this is what your screen looks like. Okay. So your screen looks like this. I took it right at the wrong time, so the cursor was flashing on the Y. That's this. This is a Y1. Okay. And so from there, you just hit OK. Now it doesn't give you anything, and it'll give you this weird X value, bounds, whatever. Just hit the solve button again. Okay. And well, I guess it is 1.571. Is that the answer? Yeah. So then you get a screen like, let me move this.
Do you hit enter or graph?
Neither. You hit C, well, graph, because that's the solve right above it there.
Yeah.
Here, I'll show you here.
Okay.
Okay, so remember that the buttons, so the buttons at the bottom, or this at the bottom correspond, any of these tabs correspond to the top row of buttons. So this solve would correspond to the graph button on your calculator. Okay, and then this is the answer. Okay, and of course you would either truncate it or round it, whatever. Okay, 1.571 is probably what you have. Okay, just again, just another option. I think, this is my opinion, it takes less time, especially if you've already entered into your y equals screen, right? Because then, for the very first equation, you know, I didn't have to do anything except type it in. So it saves a little time. And while this FRQ seems easy, maybe you're going to need that time somewhere else on a different one, right? So anyway, all right, let's look at the scoring guideline. Okay, so what I want you to do, and I want you to be fair, okay, because I want you to give me an actual score. It's not going to be worth your grade or anything. I just want to show you something as a point of comparison here in a second. All right, so here's the scoring guide. I know it's very small. So 1 point. So the very first part, they literally, it seems like they don't care about anything but the answer. Okay, but the one thing I think you absolutely have to have is this v prime of 3. I think that needs to be written there. Okay, if you wrote a of 3, if you just wrote the number, I'm not giving you the point if it's me, and I'm gonna guess maybe they won't either. Yeah.
So if I do like ddx.
Yeah, same thing.
Okay.
Yeah, that's the same thing. Another notation that means derivative. Absolutely. Yeah. Did you do ddx or ddt?
Oh, I did ddx.
Should be with respect to time. So yeah, that's where you got to be careful, right? This is where, okay, right? This notation is simpler,
Yeah.
and it can. There's potential problems with the d over dt, dx, whatever. The prime, there's no issue. Okay, so there's 1 point. You use your discretion. When in doubt, what should you do? Don't give yourself the point.
Yeah.
When in doubt, take the point off. Okay? All right, the next part. So there's lots of different variations of this. Okay? So this gets to your question, Isabella. If you do it first and then add the -5 later, is that okay? My guess is yes. My guess is so long as you have this somewhere in there, that it's fine. Okay.
So as long as we have -5 somewhere in the thing, we get the point.
Right. So let's look at the guidelines over here. 1 point for expressing the integral correctly. Okay. 1 point for adding the -5 somewhere. Now it doesn't matter. The order doesn't matter. And 1 point for getting the answer. So final answer to your question, Isabella, is I think you would get the points. Okay. Yes.
So, but like in the first one, since it just says answer, would I like give myself a point or?
When in doubt, don't give yourself a point. I would say no. There is no. It's all with respect to time. I would say no. Now, I don't know if they're going to be that picky. I don't know. But for our sake, pretend they're going to be, so you fix that come May 13th. Okay? All right. How many of us have 4 out of 4 so far? Ooh, interesting. Okay. All right. Now the last 2 parts. So the second part, C, is worth 3 points. Answers. So that's interesting. So yeah, you've 1 answer for, well, it shouldn't be that hard. But 1 answer for the displacement, 1 answer for the distance, and then the descriptors. So I'm assuming 1 point for each interpretation. Is probably how they do that. So
Is it okay if instead of, I said distance traveled, I was blinking and I said, moves the distance up?
yeah, no, that's fine.
Okay.
Yep, that's fine. So long as you talk about distance in there, so long as a normal human being reading your answer understands that you've communicated you're talking about distance, they're going to give you the point. Okay, so 3 points total for that. 1 point for these answers, 1, 2 more for those. And then lastly, okay, the idea that the velocity equals the derivative of the new position. Okay, so here it says they set it equal. Now, you could have also written it as that whole crazy thing equals, and then you take the derivative 2t minus 1. You could have said it like that. Okay, it didn't necessarily just have to be in the general. Okay, question.
What if I just wrote, instead of that, I just wrote v2t equals 2t minus 1?
So right here. So you never set it equal to the original part?
No.
Okay, then I don't think you're getting it. Because the point right here says sets vt equal. So if you don't set them equal to show, bless you, to show that that's when they're traveling the same speed, I say no, you don't get that point. Okay, and then of course the answer is another point. All right, so what I want you to do is I want you to total. I'm going to come around. I'm not going to make you say what you got, but I'm going to record it for me, and I'm gonna. There's a reason. Okay, in a second, because I'm going to calculate our class average. Sorry, Grant, we don't have yours. I don't know.
I got displacement 2 digits instead of 3.
Oh, Ava.
Yeah, I know. And then
can't
I
tell
didn't even
Stan.
answer 1.
Can I see yours, please?
It's so yeah, oh.
All right. Well, you don't know who got what. Dang it, I did not. I'm sorry that I forgot I was still up there.
Wow.
My bad. I was just gonna. Oh shoot. 8 plus 7 plus 6. How many are there? 2, 4, 8. All right. So again, this is good. We should be averaging higher than the global AB. You've already taken the AB test, right?
Wait, how many FRQs are on this year?
I don't remember. I'll have to look. Yeah, I mean, it probably are, because I think there's the calculator section and the non-calculator section. I will get that information up for you.